Okay. Testing. Can everyone hear me?
Yes.
Okay. Welcome everyone to the second Python 2 workshop. Go ahead and share my screen here. All right. I was in the wrong position. Okay, we're just gonna wait a few minutes to see if someone else will come in, but I'll go over the quick agenda and introductions first. So to anyone who is watching this at a later date, you should be able to join the, I don't know if the QR code at the bottom is cut off there. It is cut off on my screen. Hello. Okay. For those who are joining later, you are able to use the QR code to join the PowerPoint, and so you can follow along with the code that's being written on the screen. So we're doing this because last time I was having trouble switching between the two PowerPoints. So this time, hopefully it'll be a little neater. This is Python 2. Last week we tried to cover as much stuff as possible, but we only got up to like lists and exceptions, which is good for troubleshooting, but it's good to expand on top of that and try to get more into our conditional statements here. So that's what we're going to go over today. All right. So I highly suggest you follow along with the code that's being written on the screen, because at the end of this PowerPoint today, we'll have an activity where you guys will be able to live solve a Hyperloop problem statement that I give to the team members every once in a while to like keep their skills up in check. So we're now delving into applications that can actually affect the team. So here's the QR code once more because it keeps covering it up for me. But if you want to join the PowerPoint, there's a chance. This is also a partnership with IEEE. So I'm not sure how many of you guys are in IEEE here. I recognize Addie, Talia, and Aaron from Hyperloop. I think it's Javier, is it? I recognize you. So this is also directed towards the IEEE team. So if they want to use this recording later on, they are free to. So hello, everyone from that club. But let's get started. Right now, we're going to go over some variable arithmetic at 2:05 p.m., which are the addition, subtraction, dividing, multiplying, and our modulus operator. You're interested in the club, or you're not in the club, but you're interested in the workshop? I see. That's completely okay too. This is open for everyone. So this workshop. Sorry, a little microphone difficulty there. I accidentally yanked out the cable to my microphone, but I should be back now, hopefully. So just let me know if things are not working out right with the recording, and I'll fix them. So we're going to go over variable arithmetic, which are the addition, subtraction, dividing, multiplying, and modulus operators, as well as order of operations. In here, we'll move on to some different type of Python actuation system in which we won't be using a script. Rather, we will be using the command line to activate our Python here. We'll also go over float division and how to do that in Python compared to some other languages you might have learned. And then we'll go over a fun one, which is string multiplication. Because in Python, you can multiply strings, which is very sacrilegious if you're talking about some other coding languages like C++. They don't let you do that. Then we'll move on to conditional statements and talk about flowcharts and booleans, and then if-else statements. So just the basic conditions. We'll go over that. And then we'll go over some loops. So while loops, for loops, in range, enumerate, how to loop through iterations, stuff like that. Should all be basic stuff that if you're in electrical engineering, you're forced to take 1310, the first coding course you'll ever take, maybe mechanical engineering as well, I'm not sure, and any other engineering major, they make you take some sort of coding class. And so that's maybe as much as you're going to get to, or we're going to get to. And I'm going to throw in Hyperloop applications here and there just to make things interesting. And then we're going to have the problem statement. So if you're on the PowerPoint already, you can go ahead and take a look at that. But we are not going to go over that until the very end. So let's see how much we can get through. All right. So from last meeting here, I like how my camera just zoomed out on there. Like, okay. During the last meeting, we went ahead and I'll post the edit link or the PowerPoint link in the description in case you guys want to go to that as well. Last time we went over GitHub Desktop, which is our software that we use. Go ahead and share my screen for this. So GitHub Desktop is the software that we use in order to access our repositories, access our code, and update them on the cloud. So last time we learned how to set up our GitHub Desktop, set up our Visual Studio Code, such that we can access our files from both our local computer and the cloud as well. We learned how that GitHub is sometimes used as a flexing mechanism for people that want to, sign up, go to interviews for jobs. The interviewers actually do look at GitHubs, so they can see which projects you're in and how much you contributed. So it's a good way to amp up your resume in case you need stuff for that. Anyways, so I'm going to go ahead and click on Open in Visual Studio Code, and we're going to begin. So this is a smaller font. I'm going to go ahead and enlarge this a little bit so you guys can see. Okay, hopefully that is good enough. Here we can see the file python1.py is what we learned in the last workshop. We're going to go ahead and do something different here. So if you've installed Python correctly and you have attached to your path, you can actually activate it from the command prompt. So go ahead and just type up command prompt, and this black window will pull up. This is usually the window that's used in like a lot of hacker movies. They make you look like a hacker and those kind of fun things. But command prompt is really cool because you can access different files from your command line. And also you can do this. So I did type Python. It automatically links itself to where I downloaded my Python file. So my Python 3.9.7. And then I can start, it's an AMD 64 version on Windows 32. So I can start using Python commands inside my command prompt. Now, isn't that cool? And just to remember, if you guys are stuck at all, because I know it's a small crowd today, that means I can be able to help more of you get stuck. So just let me know at any point if you need assistance, and I'll be able to help you. It's like a normal class. So I'm going to go ahead and begin. I'm going to pull up my PowerPoint because I'm not sure where to start. I'm going to put up my other screen. All right, we're going to start with variable arithmetic. All right, so yesterday we learned that, or not yesterday, last week we learned that there are multiple different kinds of variables inside Python. We have our integers, which are whole numbers. We have decimals, which are decimal numbers, which are called doubles. And we have strings, we have Booleans, and we can put those into lists, which are storage containers. Now, in Python, you don't need to declare the type of variable that you're going to make before making it. See, Python is very simplistic. So if you put something in, it's going to automatically recognize it. And then you can use something like the type function to check what kind of variable it is. This is a blessing and a curse at the same time, because usually you want to know what type of variable you're working with before actually activating it. Like in some C++ scripts, it's really important to keep track of that. But Python's different. So you just got to make sure you know which type of variable that your variable that you're making has, because it won't exactly tell you like if you're in the middle of a 1,000-line script. So here's how to tell easily what it is if you're stuck. Let's make a variable a equals like 65. All right. And then let's do type of a. And it says it's a class of int. Now, see how I didn't go ahead and specify what a was? I just said a is a variable and a is equal to 65. So then the Python compiler just said, okay, this is an integer. Now if I do a equals string inside quotation marks, right? What do you think will happen when I do type a?
It's going to return string, isn't it?
Yeah, it's going to be a string. So it's a class string now. And you can see how this will change the value of whatever we have in a into whatever we had as snake. Now, what would happen if I do a equals snake like this without the quotation marks? Anyone want to guess? It's not defined. So since I didn't put it in the quotation marks, the compiler doesn't know what it is because it doesn't recognize just blank letters. So remember when you're doing a string, when you're doing troubleshooting, so when you're doing print statements and all that, make sure to keep it in quotations so that the compiler can distinguish it from English rather than from just basic code. Or else you're going to have to run into like a lot of problems. So whenever you're doing any kind of variable at all, make sure if you're doing it in here in like a compiler, make sure it's make sure it's like brown text, not white text if you're trying to write a word, because it's not going to know what it is, right? Get that yellow squiggly line underneath because you have the compiler, and it goes ahead and tells you that word is not defined. So let's go ahead and play with our a variable a little more. If I do print a right now, it's going to tell me a snake, because if that was the last thing it was defined as. Now, if I create a new variable, say b, I set it equal to a, right? It's not going to tell me anything because I'm not printing anything onto the terminal. And I do print b. Does anyone want to guess what b is?
I'm going to guess it's the last defined, the last defined whatever a is. I'm not explaining very well.
That's snake, right? And so since this is a Python terminal, it remembers everything from before. So it knows what a is, it knows what b is, and so on. Now, since we're on the topic of strings here, Python is super weird, right? Python is super weird because you can multiply strings. So if I do a times 2 or a times equals 2, right? It doesn't give me an error. You know that a is snake, right? If we multiply a by 2, that means if we multiply snake by 2, which doesn't really make sense until you do print a. And you see snake, snake. I think it's just pretty funny because this is like something you can only do with Python. Every other coding language hates it. All right, so that's just something fun. That's how you can use the multiplication operator in Python. But we'll go over something more calm, more something well-known that you're used to. Let's go ahead and create a variable x. We're going to say this is 35, and we're going to say y is equal to 4.5. All right. Now, if we do type of x, it's going to give us an int. But if we do type of y, what do you think it'll give us? So y is a decimal number, and usually decimal numbers are either doubles or floats. And so you can see here, since the double is a very large number, and Python will work hard to conserve space, it'll turn into a float first, because floats are smaller than doubles. That's the only difference. Doubles are chunky numbers. Now, what happens if I do x equals x plus y? So it's going to change the variable x into whatever's on the right side, which is x plus y. And so x is 35, y is 4.5. And the answer to this, we expect, will be 39.5. And now notice that I like to call this a zombie effect, but the answer, if we do type of x now, is now a float. X before was an integer, and now it's a float. So we can just go ahead and change it like that directly. You can't do this in C++. Once you define what a variable is, like an int variable, it is forever an integer. It's never again, or you can't just change variable types like that in the C++ because it's very strict on you to make sure you don't like mess up something. But here in Python, you just need to be very careful. It's like really easy, but really easy to mess up as well. Like really easy in terms of understanding. All right, so that's the addition. So we're going to say x is equal to 5 and y is equal to 8, or yeah. And then the next arithmetic operator is subtraction. So if we do x equals x minus y. Now, if you have something like this, right, the simpler way to write it is you're going to redefine the variable with itself minus some other variable, right? So we're going to use minus equals instead. So this is basically just meaning x is equal to x minus y, except that it's shorthand because we already know that we're going to change the variable x into something new. If we press enter, we're not going to get an error. But if we do print x, we know that x is 5. We know y is 8. So 5 minus 8 would be -3. Very simple, -3. All right. So I use subtraction. Okay. Now, I know some of you guys have had C++ experience, so this might seem a little trippy to you, but I'm going to go ahead and take, I'm going to set x to 17 and y is equal to 4. Now I'm going to do x divide equal by y here. And so all this is saying is we're going to divide x by y and then set that new variable or set that new value to x. So now x is going to equal whatever x divided by y is. But x divided by y, 17 divided by 14, that doesn't go out to a whole number. If you've coded in C++ before, you know that it'll automatically turn it into a whole number for you. But in Python, look what it does. If you do print x, you can see that it turns it into a float. All right. And the zombie effect, turning it into a float, only occurs in C++ if one of these variables is already a double or a float. It doesn't work if both of these are an integer, because an integer divided by integer would result in an integer, right? Python's weird. It says that an integer divided by integer would be a double. So that's what we have. So I'm going to go ahead and set this x to 17 again, that y to 4. Now, what if we want an integer as an answer? What if we're making some sort of division calculator and we want the whole number to be spitted out, while we want the remainder to be we want the remainder to be some other function as well. So if we're dividing two numbers and we want the whole number, we need to do something called float division. Now, float division is really simple. All we do is we say x equals x and then 2 slashes instead of 1, y. And now it spits out an integer. So the double slash means that we have float division. And I'm pretty sure this works with the simplified syntax as well. So we can have x double slash equals y, and then it'll go as 4. So we've covered float division now. So now you can pretty much go ahead and make like a calculator that divides two numbers and then gives you the whole number and gives you the remainder, but you're missing one step, right? If we want to find the remainder of 17 and 4, there's one other operator you have to use. And it's not an operator you see a lot in algebra because it's not used that much. But if I set x equals to 17 and y equals to 4 again to just reset our thought process here, we have to use the modulus operator. All right, that's the last operator we're talking about today. And so the modulus operator will find you the remainder of whatever your division is. So if we do x equals x mod y, 17 divided by 4 has a remainder of 1, right? X goes into y 4 whole times, and then you're left with 1 over 4. That 1 would be your remainder. So if I do this and I do print x, it'll give me 1 as a remainder. All right. So we're going to go ahead and do x equals 17, y equals 4 again. And then we're going to print, or we're going to do x is mod equal to y, just to show you that this works. And it does work, because it's 1. All right. So at this point, you should know that in Python, we have operators, arithmetic operators for variables, such as addition, subtraction, multiplication, division, modulus, and float division. All right. And if you don't like float division, you can always go the difficult route of trying to change a data type from one to another. A very good one I like to do, usually because for Hyperloop circumstances, we're passing data back and forth. If we have a string and we don't want, or if we have an integer, right? And we want to put it inside a string and it doesn't work because it can't concatenate an integer and a string, you want to turn that integer into a string first. I know that sounds really confusing, but just let me demonstrate what I mean. So let's say this is a very obvious number, and this is a new variable. So my number is going to equal 50. Now, if I do type of number, it will give me that it's an integer. Now, if I do print, hello, my favorite number is, and then I concatenate the number here. Then it's going to give me an error saying it can only concatenate a string to a string. So it can add strings together, but it can't add an integer together. We need the number to be a string before we can print it out. So what we do is I'm just going to press my up button. My up and down arrows actually give me the last command. So if you want to use that in a command prompt setting, you can. So I'm going to go ahead and just add str before and right after my number. and now it'll work. So the string function, remember, it turns a integer number into a string number. This also works for floats. And this number type is now a string. So if I do number equals string number, and then I do type of number, it'll now say it's a class of string. Alrighty? Did I lose anyone yet? Everyone still following along?
You can put that, I'm losing the word here. I'm sorry. Not commands, the string parentheses, you can put that in the, okay, line 41, right? Instead of number, you could put str in parentheses number, and then it would work, correct?
Yes, so I did that right here.
Oh, I completely missed it. My bad.
No worries. Okay, so at this point, let's go ahead and make a fun little calculator here. So Python 2.py, I'm going to name this file. And I'm going to make a comment here. I'm going to say that this, let me make this bigger. So this calculator divides two numbers and returns us the whole number and its remainder in a formatted string. Okay, so this calculator divides two numbers and returns the whole number and its remainder in a formatted string. All right, now I'm going to code this live. I haven't prepared this in advance, but I would like you guys to try to do this yourselves first. So I'll give you guys a head start. Based on what we've learned of variables, printing strings, formatting strings, and debugging, how would you solve this prompt? I'll give you like a minute or two to think about it and maybe write some code, and then I'll go over the solution. Starting now. In like 1 minute. Hope you guys have some like ideas about how to do this. So does anyone in the chat right now want to give me an idea of where to start? No? All right. I'm gonna go ahead and solve this, okay? So let's see here. Two input functions. All right, good. So let's create our numerator. And let's say this is input. And we want our numerator and denominator to be integers, right? Denominator. So because these input functions will give us a string, if we look closely, right, it says that it will return a string. We want this to be integers, so we're going to do int. And then to make this prettier, we're going to do prints. Please enter the numerator. Or, and then print. Please enter the. All right. And then, good, Talia, use double float division and then our modulus, right? And so we're not going to consider edge condition in this case. So we're going to say here our whole number is equal to the numerator / denominator. All right. And then our remainder is equal to the numerator, and then mod the denominator. In our formatted string, we're going to do print, and then here I'm going to use an F string, and we're going to go ahead and do our the whole number is whole number, and our remainder is well, you can do this if you want to be boring, but you don't want to be boring, so we can just do another F string. Can say the answer is, and then whole number, and then usually they do like R and then remainder. So just multiple ways of formatting your answer, and both of these things do work. I'm going to try the first one first to show you guys. If you look in the down below our terminal window, we'll have our numerator. Let's say 45. Whoops. So click down here, 45. Denominator would be 6. And then our whole number will be 7, and our remainder is 3. So you see how our code just puts them in there? We don't need to turn them into strings before putting them in, because this is not concatenation. This is a string format. And so if we comment out the top one and put in the bottom one, we can go ahead and see that we'll put in the same thing. So 45 and 6. The answer is 7R3. Okay. So when you're formatting your answer, you can do it in different ways. Let me give you guys a second for anyone to catch up, and then we'll move on to the next section. I know I spent a long time on variable arithmetic, went over time, but hopefully we can consider a little bit of conditional statements and a little bit of loops before we go. All right. So the basis of conditional statements relies on operations. So we need to figure out if some statement is true or false, and then if it's true, we do the operation. If it's false, we just skip it. Right? That's our if-else statement right there. Now, different types of conditionals can include comparisons. So if we have our variable g, or f equals 45 and g equals 35, if we do f is less than g, it's going to give us false because f is more than g, obviously. If we do g is more than f, then it's going to, it's still going to give us false because g is less than f. But if I do g is less than f, so this is a true statement, right? It would be true. So there are different types of conditionals you can have. If you look on the PowerPoint on slide 4 here, we have and, we have or, we have not, we have equals, equals, greater than equals, less than equals, not equals, less than, or greater than. So a good example of this would be, let's say if f is equal to 30 and g is equal to 30, and we want to check if f is equal to g, we must put double equals, right? Because to distinguish it from like our regular declaration. F not equals g, we know it's false because f is equal to g. And then we can have like a not f, and that's false as well. So the top three of them are used to compare two conditionals. So we've only worked with one so far, and that's comparing two variables and what they contain. What if we do something like, let's say a is equal to 3, b is equal to 4, c is equal to 5, and then d is equal to 6. All right, something more complicated. If we have 4 variables, and then we do a is less than b, and c is less than d, who wants to guess what this will print out?
True.
So be true, right? Because when we use the and comparison, now we are comparing two conditionals. And so if the left conditional is true and the right conditional is true, then it's going to return true. All right. That's the fun part about it, because you can like infinitely stack them. And so that's very fun. Now, if you do, even if one of them is false, let's say a is greater than b. Now, we all know that's false, right? If we use or, C is less than D, this would still print true because or, the operation or, just needs one of them. Just needs one of them to be true in order for the whole expression to be true. Now, you may have seen and or operators in somewhere else. So in C#, they come as these two ampersand symbols, and or would be these two double lines. But in Python, we can use these operators. Now, an important Python operator that many people get confused on, including a few of my friends when they first start, is the not operator. Not is very important because it tells you if the variable you're working with is empty. And what do I mean by empty? So let's say my variable u is equal to a blank string. If I do not u, this will be true because there's nothing in u. All right. If I do u equals 0 and I do not u, this will be true because there's nothing in u. For a string, a not operator, for a not operator to be true, a string needs to have nothing in it. For a not operator to be true, an integer needs to have nothing in it, which is 0. 0. And for a Boolean, let's say u is equal to false, and if you do not u, it's true. All right. Very confusing, very non-intuitive, but it's very useful for determining if there's none type inside a variable. And so when you get to dependencies, let's say u is a none type, right? And I do not u, it's going to be true. Now, we don't know what none is yet, but let me just tell you, it's a pain to work with. Usually you get none types when your dependencies or when the libraries you're calling in from your sensors aren't working. So they return none. And then you get this. So when you're trying to troubleshoot something, you usually use not u to find if that's the case, if the sensor is actually returning nothing. And then you'll know that that sensor is broken. All right. Let's go over conditionals. We can use these comparison variables in conditionals to tell us whether something is true or not, and to do something or to do something else. So if we have an if condition here, I'm going to say my A is equal to 10 and B is equal to 100. Now, this is a cool thing because I can do this in command line Python. If I do A is less than B and I put a colon afterwards, look what happens. It lets me type on. So if A is less than B, if this is true, I'm going to want to print A is less than B. Oh, I forgot indented. Okay, so prints A is less than B. So this is why indentation is extremely important in Python. There's no semicolon, so it doesn't know where to end the line. So only indentation will tell you when the line's going to end. Okay, if I press enter, this is not going to do anything yet because I haven't finished my statement. It doesn't know when I'm going to finish my statement, right? I can have more in this if statement. So I'm going to say else to end it. Now, else will do everything that the initial condition won't. So if A is not less than B, then it will jump to the segment else, and it will write code in the second half. So else, I'm going to say A is not less than B. All right. And I'm going to press Shift Enter to end my statement. Now, because A is 10 and B is 100 and A is less than B, this statement is true here, which means that if true, it's going to do whatever's inside here. Now, if false, which means that this conditional returns false, then it's going to do something else. So else print A is not less than B. Does that make sense for everyone here? I don't want to lose anyone yet. It's going to get more complicated later on. Please feel free to stop me if you're stuck. All right. So that's an if-else statement. Now, a very popular activity to do with like in your coding class is like a grade calculator, right? You can have a lot of these conditionals inside of something like a grade calculator. And all the grade calculator does is say, I'm going to input a grade. So grade input. And I'm going to write a bunch of comments here. All right. These comments are good. So if my grade Now this, what I'm doing here is called pseudocode, all right? Pseudocode is like coding, but in words. So if my grade is greater than 90, I have an A. If my grade is greater than 80, I have a B. If my grade is greater than 70, then I have an A. Or C, sorry. Wouldn't that be nice? And then I'm just going to end it here. I'm going to say if my grade is any lower than that, I have an F. Now we're going to code this using conditionals, all right? So first I'm going to go with my top layer. My top layer says if my grade is greater than 90, I have an A. So if my grade is greater than 90, then I'm going to print you have an A. And you see how this is very direct from our text to the code? Our first line says, if my grade is greater than 90, and I'm here saying, if grade is greater than 90. So this is my conditional because I'm comparing two things. I'm comparing whatever grade is to 90. Now, there is a problem to this, though. This code will not work when I run it. Does anyone want to tell me why?
It's because input is picking a string.
Input is a string. That's good.
Yeah.
So in order to get this into an integer, we want to do int input. Now this is a new function. You guys haven't learned this yet, but our integer function, if we hover over this, states that it's going to convert a number or a string to an integer or return 0 if no arguments are given. Now notice that it'll return 0, which means that that's our not condition. When we talked about not operators, that's very important. All right, let's finish the rest of this. Now, if I want multiple if statements, if I have multiple conditionals to check, then I'm going to use elif. In Python, it's elif. In C++, it's elsif. In Ruby, it's something else. All right. Every coding language has their own version of this, and some of it's the same, some of it's different. For elif, we have to add an additional condition. So if this initial chunk of code is false, we're going to jump onto the next line of code. So we're going to jump here into the elif statements. All right. We're going to say elif grade is greater than 80, right? Because it's not going to get here unless this is false. So you may have heard of, oh, I'm going to say grade is greater than 80 and less than 90 or something like that. It's not necessary unless you do multiple if statements. If the code prints you have an A, that's the end of the line. It's not going to go into elif, right? This whole block is done. So elif grade is greater than 80. I'm going to go ahead and print you have a B. I'm going to keep going. So elif grade is greater than 70. I'm going to say print you have a C. Now, I'm going to end it here because anything lower than that is an F, remember? So if my grade is like 50, this is not going to be true, right? 50 is not greater than 90. 50 is not greater than 80. 50 is not greater than 70. So it's going to pop it to here. So else just takes care of everything else we're not concerned about. So I'm going to say else you have an F, sad face. All right, let's try this out. I'm going to press play. And then, oh, what was it saying? The ampersand character is not allowed. Where did I put an ampersand character? Wait, huh? Okay, I don't know why it just like bugged out on me there. But I'm going to say my grade for this class is like 95. Woo, I have an A, right? Because our grade passed through this first barrier. It's like going through like rounds of competition, right? This is like the first round, this is the second round, and the third round. So if grade is greater than 90, it's going to print you have an A. It's not going to go through anything else, right? Because I already had got what I wanted. So it's going to skip through the rest and end the code. Now, if I say something like, if I have an 80, if I say I have an 83, then I have a B, because 83 is not greater than 90, so it moves on to the second line, but 83 is greater than 80, so it's going to say you have a B. All right, Okay. And I'm going to test the fail condition. So if I failed, like I say, if I got a 50, I have an F because it passed through all these conditions. Very simple grade calculator, but using if conditions. All right. Anyone have any questions so far? No questions? All right, we're moving on to loops then. I know I'm kind of speeding through this. We haven't covered flowcharts, but that's probably a discussion for maybe next week when we get to socket. All right. Okay, so there are two main types of while loops. All right, or sorry, I like the loop design of the slide because it has an infinity on it or hyperloop. Get it? So our while we're talking about loops, we're talking about repeating things over and over again, right? Like the name, we're looping things. So there are two main types of loops. We have while loops and we have for loops. Why do we use while loops? Well, while loops are mainly used if we don't know what condition to stop at, right? Let's say the most popular one is while true. All right, let's me create a new file here called loops.py. The most popular loop we use in Hyperloop, get it, is the while loop. And we use while true a lot because we want to make a synchronous procedure. Now, the word synchronous may sound large, but all it means is we want to keep track of when everything is running. So the time at which this happens, the time at which this happens, all has to follow a certain order. The opposite of synchronous is asynchronous. If we don't want things to follow a certain time, then and we have to like press a button or something. So button presses are asynchronous because they don't follow the same pattern of pressing. I don't press a button every like 1 to 2 seconds. I press it whenever I want. So that's an asynchronous procedure. But while true is synchronous. So if I have stuff going on in here, and let me say I import a time module, import time. They go ahead and do while true, and I'm going to go ahead and do like print hello. I'm going to create a variable called counter just to show you how the while loop works. And then I'm going to turn this into an F string. And then I'm going to add the counter. And inside the while loop, I'm going to do a counter plus equals 1. So I'm going to add 1 to the counter every time it loops. All right. Now, this is very dangerous code. And does anyone see why it is very dangerous?
There's nothing that's going to make it end. So it's going to go on forever, and it's never going to compile.
True. Yes, that is correct. Another reason why it's so dangerous is because this will run really fast. It's a while loop. It's going to keep counting and counting. And sometimes we want to give it some sort of delay, some sort of artificial delay to let the computer think. It's kind of like a human, you know, it needs time to think as well. So if we do this sort of thing for counter plus 1, it uses very low memory. So it's not going to break our computer. But if we do something like retrieve data from a sensor and we don't include a delay, it's gonna have a hard time keeping up, you know? So what we're going to do here is we're going to go ahead and insert a time delay. And in Python, we can use the module import time, which is built in order to do time.sleep. And this will return is in seconds. So I really like IntelliSense because it gives you a description of how many seconds have passed, or it gives you a description of what the function says. And in this function, it says that it's going to return, or whatever we put in here as an argument, it's going to wait that amount of seconds. So I'm going to put 1 here because I want to wait 1 second. And then when I run this code, it's going to begin counting in the terminal window at a rate of 1 number per second. And then it's never going to stop unless we stop it ourselves. All right. Cool loops, basic counting mechanism. I love it. However, like Addie said, it's a problem because we don't know when to stop this. And usually in procedures, we want to know an exact time in which we need to stop our code. So anyone here want to suggest something that we can do in order to stop the code from counting on to infinity? We just learned it. we'll use a conditional. So in fact, we can actually use a conditional to stop this from happening. We're going to say some random number, let's say a low number. So if I'm going to decrease this to 0.2, and I'm going to say if counter equals, right? If counter equals 30. So if our code counts to 30, I'm going to print ending code. All right. And then I'm going to insert a break statement. This is a very powerful piece of code here, this one-line break statement. What this does is it just gets out of the while loop wherever the code is. So if the compiler is kind of like this red dot here, it's reading down the while loop, it reads from the top again, and it'll do this infinitely over and over and over and over and over again. This break statement will just get it out of the loop, right? So when it reaches 30, it's going to end the code, and then it's going to get out of there. So let me go ahead and run this so you can see. It's going to go really fast, all right? So it's counting up, it's counting up, it's counting up. And when it gets to 30, it's going to end the code. Now, I said when counter equals 30, but it doesn't show hello 30. And why is that? Can anyone tell me?
Because you broke it when it equaled 30, not after.
Right. So what would I do in order for me to see that it says hello 30?
You'd use 31 in the code.
I can use that, but sometimes we don't want to be redundant. We only want 30 to be a case, right? So that would be a correct answer, which is really good, Addie. But I can just go ahead and reverse the order of my statements, right? Now, if I do that, let's look at what happens. Uh-oh, it still doesn't say 30. And why is that? Because I put counter after my print statements. So order matters in code. That's the lesson I want you guys to bring out from today. This should work now. There we go. Now we have a 30. So there's different ways of approaching things. You usually want to find the most efficient way. If you're a CS student, that's going to be a very important thing to have. If you're not a CS student, then it's not that important unless you are making a very high time sensitive robot. Hey, are you? So that's the use for while loops, but there is a better way to go about this. So here in this piece of code, we know when we'll stop the code, right? We want to stop it at when counter equals 30. And we use while true, which is good, but sometimes kind of redundant because we broke it. Using while loops, sometimes we want to say that while loops are usually used for some kind of sensor condition. So if, let's say I replace this with while sensor dot return ultrasonic. Now this is a completely ridiculous piece of code. It's not going to work, obviously, because I don't have this. But if you're working with robotics and you want to see if the sensor has returned a code or not, and you could say while sensor.return. So if this function returns true, which means if data points come from the sensor, you're going to run everything in it. Now, suddenly, if the sensor decides to break, then this function will give you false because there's no sensor there anymore. So it's not going to run all of your code. So that's the point of a while loop. Everything inside of it is synchronous, with the exception of the condition itself. So the condition itself is asynchronous. That's when we have to stop the while loop from happening. And it's a fail-safe measure. It's a safety thing. We want it to be safe, right? We don't want our robot to keep running on 3 legs after one is broken. So that's the point of the while loop. And I'm going to go over for loops really quick and then present a little prompt. So if we want an iterative process, right? An iterative process being counting a variable. So I'm just going to change this back to true. And I'm going to comment this out. I'm going to say while loop. Okay. Our second case, if we want to count up to 30, let's use our previous example. We have for loops we can have. So I would suggest you use the W3 schools link to read up more on for loops after this, because there are different types of for loops. And I'm only going to introduce like the first one, which is just the for loop that counts up to a certain number, right? So I'm going to do for x in range. Okay, so here's the deal with variable names. I like to just present this as a experience from experience. Usually people use I and J as function or for like loops. I use X if there's one for loop. One for loop meaning that it has an O of n complexity, a linear complexity. I use X. If it's an O of n squared or exponential complexity, which means there are two for loops nested in each other, I use I and J. So this is just for some more advanced people who have experience in this and are saying, why are you using X? That's terrible. And I just use X because it's one layer for loop. So for X in range, now let's look at this function here. The range will return an object that produces a sequence of integers from start to stop like that. So if I do from 0 to 30, and I do print f hello world, and I'm going to do time.sleep 0.05. All right. This is about the same code as this right here, but this code is about 10 lines compared to the 3 lines it takes up this code. And let me show you the functionality is just the same. So what the for loop does is it takes this variable x, it repeats it over 30 times in the range from 0 to 30. And for each time, it's going to print hello world. And I just forgot to put in x. So you can use the variable inside the for loop. And there we go. And it doesn't print in 30 because it does not count the last number. So Addy would be correct in saying 31 here, in case you want the 31. So for in range, it does not take the last number. So you have to add 1 to it if you want more. And there you go, the same code, but in less lines. Unless you're getting paid like by line of code, which I don't know if people actually do that these days. Like, honestly, I'd be rich if they paid me by line of code in some of my projects. But this is how you optimize stuff. For loops are optimized, not as optimized as like hash maps or stuff. If you go into data structures and algorithms, that's more of your zone. But for loops are just good for compacting code compared to your while loop. Does anyone have any questions so far for all of this?
I don't know if this is kind of off topic. You're talking about doesn't include the last number in 0 to 30 of that range. Mm-hmm. When you're doing a portion of a string, is that the same thing? I can't remember for Python.
Yes. So yes. Okay. So same for a list, actually.
Okay, cool.
But you got to be careful. Let me just put up an example here, right? Let's say you have a list of stuff, and that's equal to like 0, 1, 2, 3, 4, 5, right? Mm-hmm. And let's say I want to print the stuff in this list. Now, how many elements are in this list, would you say?
There's 6.
Right. So I'm going to say for x in range from 0 to length of list of stuff. And then I'm going to go ahead and print x, or I'm going to print list of stuff x. Is this going to throw an error?
Wait. Don't think so.
And you'd be correct, right? The length of list of stuff is 6. When we iterate through a list, we start from element 0. So right. This would be 0, this would be 1, 2, 3, 4, 5. And it stops at 6. So it doesn't try to get the 6th iteration of this list here. So let's run it. And it stops, and no errors, and we are happy. All right.
Cool. Okay, thank you.
Yeah, I don't know if that answered your question, but like.
Yeah, I just I haven't looked at Python syntax in a while. I was just wanted to make sure that it was the same thing, where it didn't count that last last number. Cool.
Yeah, you'd be correct. It doesn't count the last one. All right. Okay, so if there's no more questions, I'm going to go ahead and present the problem statement for all of you. If you are in Hyperloop, I'd like you to give a crack at this problem statement. All right. If you're not in Hyperloop, you can still take a crack at it. Send it in the Hyperloop channels if you are a member. You can come to the next workshop and I'll give some time for you guys to present the solution. But this is a very real problem statement I like that actually gets you involved in like kind of like Hyperloop activities. If you're watching this as a recording later on, you can go ahead and try this problem statement out, send it to either me, or if you're in IEEE, you can send it to one of your leads or in the Hyperloop channels. I should create a channel that you can put these projects in, actually. That'd be cool. But let's read through this, all right? So the prompt is to write a Python script to follow the description of a realistic control system. So in Hyperloop, we are going to work with control systems a lot, and some of these things are very finicky in the way they work because they retrieve data from sensors, and they must also send out data as well. The CPP Hyperloop pod is accelerating to a speed of 200 miles per hour from initial velocity of 0 miles per hour, which takes about 7,200 milliseconds of time. If the time is at a multiple of 100 milliseconds, we will retrieve a data point from the IMU. The IMU is an international measurement unit, by the way. It is a sensor that can tell you the speed of the pod. Let's keep it simple like that, all right? If the time is at a multiple of 750 milliseconds, we will retrieve a data point from the DS18B20 temperature sensor. Temperature sensor, we know what that is, right? Gives us temperature. And this is realistic because our temperature sensor has a greater resolution than our IMU. So it takes longer to get data from it, which is really important when you're working with threading and Arduinos in particular. If the time is at exactly 5,000 milliseconds, the pod will autonomously retract its brakes and prepare for travel at full speed. Now, this is an input from the control system. The other two are outputs because we get data from them, right? Or you have to think about them from either the Arduino's reference point or the pod's reference point. From the Arduino's reference point, the sensors are going to act as inputs, right? The IMU gives data to the Arduino. The temperature sensor gives data to the Arduino. The Arduino sends out a signal that retracts the brakes. And that's kind of like the input-output logic we use for coding in Arduino. If we're talking about the pod, then it's different, right? The pod is outputting data and taking in a control. So just be very clear when you're talking about what control system you're using, which is like why I like to be very clear when giving directions, hopefully. And all of you should be too. Clear directions are make for happy engineers. When the pod reaches maximum speed, it will print out the number of data points from the IMU and the number of data points from temperature sensor that the pod took over the course of its startup sequence. So just a hint, you'll need a couple counter variables inside your loop. All right, so you don't need to like get actual sensor data. You can just say use print statements instead, but just kind of like pseudocode this and try to get it to work in one Python script. And I will be interested in seeing solutions. So if in fact you are a team member of Hyperloop, or if you're not, that's completely fine. Just DM me and I'll give you feedback and see if this would actually work in a real setting. All right, so I think I'm at the end of my time here. Arya's here and ready to take over. I'm gonna give him host. But as of right now, does anyone have any questions at all for the things that we covered today? No one at all. All right, if there's no questions, then our contact information is here. We're at cppxhyperloop@gmail.com. Our Instagram is CPP Hyperloop. If you're an IEEE, feel free to visit them as well. We love partnering with them. We get like more people in the workshop that way. Our Discord is there. Please feel free to join it if you haven't already. And that will be all. And down here in the comments, I just put a link to learn more about Python because I can't cover everything. I'm mainly here to teach you what you can't read online. So the experience is what you're here after. Okay, so I'm going to end it here. But thank you everyone for coming today. Hope you have to stay for the SolidWorks workshop with Arya in the nearest hour. And if that's everything, I'll see you guys. So thank you all for being such a good audience today. And I hope you come back for another workshop next week. So next week's Python 3. Thanks, everyone.